So this video tutorial will discuss how to solve problems like this. So in this problem, we have two parts. In the first part, we are given that x is acute and that 2 times the square of secant x plus 7 times tangent of x equals 17. And we need to find the exact value of tangent x. Okay, so let's start with part A. So how do we do this? This is an equation which is consisting of two different ratios. We have secant and tangent. So again, how do we solve trigonometric equations where we have two different ratios? We need to find a way to make it into a single ratio only. And that will be done using identities. So once again, we have several identities. So we have to find the identity that connects secant to tangent. And that is one of the identities that we learned in day 1, wherein we have secant squared x is equal to 1 plus the square of tangent x. So this is the identity that we will use for the equation. So now the equation becomes, instead of secant squared, we're going to use, so 2 times, instead of secant squared, now we use 1 plus the square of tangent from the identity plus 7 times tangent x equal to 17. Okay. So now we see that the entire equation is in terms of tangent. Unlike here, we have two different ratios. Then from here, we simplify. So now we have 2 plus 2 times the square of tangent x plus 7 times tangent x equals to 17. That is again a quadratic equation in terms of tangent x. So let's solve the quadratic equation now, making one side 0. Tangent x minus 15 is 0. You can apply substitution or you can directly get the values of tangent x. So I will directly get the values of tangent x by using mode 5(3) in the calculator. So a is 2. That's the coefficient of the term with square. B is 7, the coefficient of tangent x. And the constant c is negative 15. So I have the first value of tangent x, which is 3 over 2. And the other value is negative 5. Okay. So at this point, we will pause and we go back to the problem because there is a given information about x. It says that x is acute. So what does this mean, that x is acute? Here we have two values for tangent x. So when x is acute, that means angle x is found in the first quadrant. And tangent, since we're dealing with tangent x, in the first quadrant, tangent is positive. Therefore, we are going to reject this value of tangent x because x is acute. If x is acute, then x is in the first quadrant. And in the first quadrant, tangent x should be positive. That's why we're rejecting this. Have we found the value we're looking for? The exact value of tangent x? Yes, we did. So the exact value of tangent x is 3/2. So this is the answer we are looking for.